All right, for Algebra 1, we're doing 3.2 ratios and proportions. I'm sure you're thrilled that we're moving on from literal equations. All right, so our objectives today are to use proportions to solve problems and to determine unit rates, as well as convert given rates into equivalent rates. So we're going to be using some unit multipliers and dimensional analysis again. Okay, so hopefully this is transferring over to your science class as well. So let's look at some vocabulary first. First thing we have, a ratio, okay, is a comparison of two numbers by division. It is written as a fraction most often. Okay, so a fraction is a ratio. Okay, it's not always written as a ratio as a fraction, but a fraction is a ratio. All right, next up, we have a rate. Notice a rate is a ratio, so it's a fraction. Comparing numbers with different units. Okay, if it has different units in it, then it is a rate. Okay, that's all it has to have. A ratio can just have numbers. It doesn't have to have any units at all. A rate has units. All right, then a unit rate. So it's a rate, going back to each of these kind of link, in which the denominator is 1. That's the key here. In a rate, the denominator is 1. It's per something. Okay, miles per hour. I ate 6 cookies, or there's 6 cookies per package. Those kind of things, per 1. Okay, so then if we look here, these are all ratios, because they're all some form of fraction, even though they don't look like it. Circle the rates and square the units. Okay, so we want to circle the rates. Remember, those are a ratio comparing numbers with different units. Okay, with different units. Which ones would be rates? Okay, 3 minutes for every 4 questions. That is a ratio. Anything else? Okay, 5,280 miles per 1 kilometer. Okay, that one is not a rate because it's per 1. That's a unit rate. This one, however, 60 miles in 2 hours or per 2 hours is a rate. And now we want unit rates. We want to square, and I'll change our colors. We'll put a square or rectangle around the unit rates. Maybe I should say a box. Okay, this one is a unit rate because it's 6 miles per 1 hour. Okay, so it's a unit of 1 in the denominator. 5,280 miles per 1 kilometer is also a unit rate because it has a 1 in the denominator. 45 sixtieths and 1/3 are just ratios. They don't have any units, so it's just a ratio. They're not rates and they're not unit rates. Okay, so those are just ratios. So hopefully that helps you out with understanding the differences between those 3 things. So let's look at example 1. A school of 312 students has 168 girls and 20 teachers. Find the following ratios. So we want to find the girls to students. This ratio is going to look like, I'm going to say it's G over S, the girls to the students. So we have 168 girls, so I'm going to put that in my numerator, over how many students? Hey, look at that, 312. That's it, right? Like, I shouldn't say that's it. We could reduce this, okay? What they have in common would be 7/13 if we reduce it. But again, like it really is as simple as 168 over 312 before we reduce it. All right, the next one is boys to students. So I'm going to have my boys in the numerator, my students in the denominator. All right, they didn't tell us how many boys though, right? 168 girls, 20 teachers, 312 students. We're going to have to do some math. We're going to take the number of students, 312, subtract the number of girls, 168, and get the number of boys, which would be 144. So my ratio of boys to students, okay, boys is 144, and students is still 312. And the nice thing is that this reduces to be 6/13, which technically you wouldn't have even had to do this math over here, really, I guess, because if 7 out of 13 students were girls, 6 out of 13 students would have to be boys, because 7 plus 6 equals 13. So you could have also went that route to solve it. Saved yourself a little bit of time. Okay, let's look at the ratio, C, of girls to boys. So our girls are going to be on top. Our boys are going to be on bottom, or our denominator. And so, again, we could kind of take the long way here. If we didn't reduce, there's 168 girls. We did the math to find there's 144 boys. Or if we took that shortcut, you know, the 7/13 and 6/13, then we know there's 7 boys to every 6 girls as well. So it could have been 7/6. And you can check the math and reduce those, and they will reduce. All right, now we're changing gears a little bit. We want the unit rate of students per teacher. Okay, so we want students per teacher. So students goes in the numerator, teachers go in the denominator. We have how many students? Excellent, 312. We have how many teachers? Great, 20. All right, and so if we want the unit rate, we are literally going to divide 312 divided by 20. Okay, so 20 goes into 31 once. We subtract 20. We have 11 left over. Bring down our 2. 20 goes into 112 5 times. We subtract 100. We have 12 left over. So it's 15 and 12 20ths. Okay, so we could simplify this. They both have a 2. 2 goes into both of them. 12 divided by 2 is 6. 20 divided by 2 is 10. So 15 and 6/10. So this equals 15 and 6/10, or 15.6 students per teacher. Yes, you can't have a decimal, right? You can't have 6/10 of a student, but that would be what the ratio is. We would leave it like that. 15.6 students, or about 16 students per teacher. Okay, so we were able to find rates and unit rates from that one problem, several different ones. Now, next up, any rate can be converted to an equivalent rate with different units. We've been working on this. To do so, you're going to use dimensional analysis and unit multipliers. Okay, so examples. We can convert 60 miles in 1 hour to kilometers per hour, right? Notice our unit rates changed. We went from miles per hour to kilometers per hour is what we're trying to do. But in order to do this, we're going to need to use our unit multipliers. Okay, these are rates with different expressions representing the same quantity in the numerator and the denominator. So every unit multiplier has 2 different setups, which we've talked about. So this one, like if we look at these 2, we have 1 mile over 5,280 feet. These 2 things are equal. Okay, so they're equal to 1. Or we can set up the unit multiplier as 5,280 feet over 1 mile. Either of those can be used in our problem. It depends on what we need. The cool thing about unit multipliers is their value is always equal to 1, which is why we can use them, because we're not changing the problem at all. And multiplying by 1 or more unit multipliers renames the ratio. So it's equivalent, but it has different units because we're renaming it. That's it. We're just renaming it. All right, so let's jump into these examples. Let's clear this and we'll move up. Okay, example 2. Use a unit multiplier to convert to the desired unit. All right, so in A, we're going from feet to yards. So we have to think about the unit multiplier that we need, or maybe the conversion that we need, right? Because we know 3 feet is equivalent to 1 yard, or we could write it as 1 yard is equivalent to 3 feet. We have to think about, okay, that's what I need to hear. Right now, I have 28 feet. Okay, and that's over 1. And I'm going to multiply that by one of my unit multipliers. But I want the one that's going to cancel the feet out and leave me with yards. Well, that's going to be this one, because I have feet in my numerator, so I need feet in my denominator, so they'll cancel. So I'm going to say, well, 1 yard, multiply this by 1 yard over 3 feet. So my feet cancel. And I'm going to do 28 times 1 is 28. 1 times 3 is 3. And my unit is yards. And so now I can simplify this. 28 divided by 3 doesn't go nicely, right? 28 thirds. But 7 goes. 28 divided by 3, right? It would give you 9. Sorry, that would give you 27 with 1 left over. So this would be 9 1/3 yards. So 9 1/3 yards. Or if you did it in your calculator and you got a decimal and you got 9.3 repeating, that's fine too. Okay. But the important step here, is to remember whatever you have, whatever unit you have in your numerator, the unit in your denominator is going to cancel. You're trying to set it up so your units cancel. All right. So for our next one, we're going from inches to centimeters. So we need to think, well, 2.54 centimeters is equivalent to 1 inch, or 1 inch, we could say, is equal to 2.54 centimeters. Okay, so we've just got this rate here. They're equivalents because it's equal to 1. So we're starting with 62 inches. So again, we've got 62 inches over 1. And which unit multiplier do we want to use or need to use? Excellent. It's going to be this one because our inches are in the numerator, so we want them in the denominator to cancel. So 2.54 centimeters is equal to 1 inch. Our inches cancel. So now I have 62 times 2.54. 62 times 2.54 equals 157.48 centimeters. And then 1 times 1 would just be 1. So this equals 157.48 centimeters. 62 inches equals 157.48 centimeters. So again, we've already done this sum. We're just digging deeper into it. Example 3. About 8 minutes into liftoff, a space shuttle is traveling 17,000 miles per hour. How fast is this in feet per second? Okay. So we're taking 17,000 miles per hour, and we want to know how fast this is in feet per second. All right, so we're going from miles to feet. Okay, which means we need to know the conversion between those. Like 5,280 feet equals, I could write it like this. I'm going to go ahead and write it as a rate. Hopefully get you guys in that habit. 5,280 feet is equal to 1 mile. And then we also can write this as, 1 mile is equal to 5,280 feet, just depending on what we need. Okay, our next conversion. Okay, we're going from hours to seconds. Okay, so we need to go from hours. I tried to change color and I failed, to seconds. So we know 1 hour equals 60 minutes. Right? Because that's the thing. In order to get from hours to seconds, we might have to get to minutes first. Go hours to minutes and then minutes to seconds. All right, so we have 1 hour over 60 minutes, or 60 minutes over 1 hour. Now you don't have to write all these. I'm trying to help you think through. And then we need to go minutes to seconds. So 1 minute is equal to 60 seconds, or 60 seconds is equivalent to 1 minute. Okay, so we're going to need several of those. All right, sadly, I'm running out of room. Again, you don't have to write all of these in your, like when you're thinking through how to do it, but you do have to show your unit multipliers to show your work. All right, so let's do the unit multiplier. We're going to have 17,000 miles per 1 hour times. All right, let's go back here. We've got miles in our numerator, so which unit multiplier do we want? The one on the left or the one on the right? Excellent, we want the one on the left, so our miles will cancel. So that's going to be 5 times 5,280 feet per 1 mile. So our miles cancel. Then we've got feet. Check. All right, next up, we want to get our hours changed. Well, now our hours in our denominator. So which one of these are we going to want to use so our hours cancel? 1 hour over 60 minutes or 60 minutes over 1 hour? The left or the right? Good. We want to use the one on the left because our hour is in the denominator, so we need it to be in the numerator. So times 1 hour over 60 minutes. Sorry, my board is getting a little cramped. So our hours cancel, and now we're with minutes. Okay, so now we're trying to get our minutes converted over. So we're going to use the one on the left. 1 minute is equivalent to 60 seconds, or the one on the right. 60 seconds is equal to 1 minute. All right, we're going to use the one on the left again because our minutes are in the denominator. So we need them in the numerator. So 1 minute times, or over, sorry, 60 seconds. So now our minutes have canceled. And notice the units we have left are feet and seconds. So to solve this, we're going to take 17,000 times 5,280 times 1 times 1. So I'm just taking each of these numbers. 17,000 times 5,280 times 1 times 1. Okay, and that's going to go in our numerator, and that's feet. That's my unit. I don't want to forget it. And then in my denominator, okay, I'm going to have 1 times 1 times 60 times 60. And that's seconds. So feet per second. All right, if I check all of that out, I'm going to get 24,933.3 repeating over 3,600. Okay, and I want feet per second, so I actually need to do this math out. 24,933.3 repeating divided by 36,000, and I'll get oh wait, hold on. I lied. 24,933 is my answer. I did do all that. Whoops. I did my math out because this is like 8,976,000, sorry, divided by 3,600. So it's 24,933.3 feet per second is your answer. Okay. Now we're ready to flip over to the back. Okay, so now we're going to talk about proportions. Okay, a proportion is a statement of equality between two ratios. All right, so if we look at this proportion, oh, I hate when my projector gets glitchy like this. Sorry for that. All right, so a proportion is a statement of equality between two ratios. So like 1/2 equals 2/4 is a really simple one that we know to reduce. But any proportion is going to look like A over B equals C over D, which is read A is to B as C is to D. A and D, okay, are called the extremes, while B and C are called the means. Okay. To solve a proportion, which you've probably done, we multiply both sides of the equation by the common denominator to clear the fractions. So here they multiplied by BD on both sides. We can see that. So here the B's canceled, and we're left with A times D. Here the D canceled, and we're left with B times C. Now, what you need to notice here, okay, notice the result is the product of the extremes. So the product of A and D, the product of the extremes, equals the product of the means. Okay, so what's multiplying the means? This is the property of proportions. In a proportion, we know the product of the extremes equals the product of the means. That's how we can always solve them and set them equal. It's really awesome, super helpful way to solve proportions. Sometimes you can look for patterns and things, but this is the easiest way. So let's put that into action. All right, so in order to solve the proportions, we're going to take the product of the extremes. So 7 times 4 is going to be equal to the product of the means, 8 times x. All right, so 7 times 4 equals 28. And that equals 8x. Then if we did our teeter-totter idea to balance, right, we would divide by 8 on both sides. All right, then 28 and 8 are both divisible by 2. So we could do this a little bit easier if you wanted, or you could get 28 divided by 8. So I'm going to go ahead because fractions are division. And 2 will go into both of these numbers. So 8 divided by 2 is 4. 28 divided by 2 is 14. Then both of those can be divided by 2 again. 4 divided by 2 is 2. 14 divided by 2 is 7. So I have 7 halves equals x. All right, another thing I'm going to pick up here. Nope, I wanted a different color. I'm going to pick up here and show you, like, when you're solving proportions, you don't have to, like, and just when you're doing any math, especially if you know you're going to cancel, you don't have to do all of the work out. We kind of talked about that a little bit yesterday. But, like, if I wanted to go ahead and do the teeter-totter here and divide by 8, right? This is why sometimes I don't write the teeter-totter. I get away from that so that you guys can see. Let me show you. So you guys can see that I'm going to divide by 8 on both sides. And I write my division as a fraction. The reason this is nice is I can go ahead and simplify and reduce here. Because like, oh, 4 goes into 8. Okay, so then I have a 4. 4 goes into 8 twice. Now I'm left with 7 over 2. My 8's cancel, equals x. Here, by doing 7 times 4, I ended up making more work for myself. which is okay. It's not wrong. We talked about this yesterday. So just kind of depends on how you want to set it up. All right, let's look at the next one. B. Again, we're solving the proportion. In order to do that, we're going to take the product of the extremes. So 7 times the quantity, x plus 9, equals the product of the means. 5 times x plus the quantity, x plus 15. All right, so here we do have to distribute. We can't get around that. So we'd have 7x plus, good, 63 equals, distribute on the other side. Awesome, 5x plus, very nice, 75. Okay, then you can draw the teeter-totter. You don't have to. I'm going to subtract 5x from both sides to get my x's together. So 7x minus 5x leaves me with 2x plus 63 equals 5x minus 5x cancels. So I have equals 75. What would I do next? Good. I'm going to subtract 63. And I'll have 2x equals 12. Next step. Perfect. I want to divide by 2. And x equals 6. All right, so I don't have to go back and find the numbers and plug those in. I'm not being asked to do that. I'm simply solving for x. That is what solving the proportion looks like. Okay, let's do example 6, and then we'll hold on till 7. I want to get the 6 in there. A car traveled 250 miles on 9 gallons of gas. How many gallons, so see how many gallons, there's my question mark, are needed to travel 360 miles? Okay, so it may help you to think of like you're going miles on 9 gallons. Like I'm going to set up my miles over my gallons. Okay, when you're solving a proportion. Because you might have noticed proportions don't have units. So this might be a helpful reminder of where to put your numbers. Okay, so that means I'm traveling 250 miles on 9 gallon. That's going to equal how many gallon? So you can put a G there or an X. I don't care what variable. I'm using G for gallon. But wait, do my gallon go in the miles? No. So see, it helps me see where that variable should go. So how many gallons should go in my denominator if I am traveling 360 miles? So the miles goes in my numerator. Okay, so just recognizing things to help you set up the problem and solve. All right, so let's solve this. Take the product of your extremes. 250 times G is going to equal the product of your means. 9 times 360. Okay. Again, you can do the math all out. You don't have to do the math out. Okay, so I'm not going to. Let's try it with just saying, all right, well, I want to divide by 250. And I'll kind of let the math fall where it will. So the 250s cancel. I'm left with G. Okay, if I have a 10 in common between 360 and 250. So 360 divided by 10 just gives me 360. 250 divided by 10 just leaves me with 25. So I have 36 times 9 over 25. Do they have anything else in common that you see? Okay, nothing else in common. Then we'll have to do some math. 9 times 36 divided by 25 is going to give you 12.96 gallons, because you know G stands for gallons. Okay, so you can use a calculator to help you with your math. Okay, you don't have to do it all by hand, but you have to show the work and show the setup. Okay, always show your setup and the work. All right, I will see you all tomorrow. Have a great day.